Hi, fellows. Did you know that bacteria are colorless? The last time you looked in a microscope, you saw pink to red bacteria. You saw blue to purple bacteria. Did you ask yourself why? Okay, welcome. I'm Sonny, and I'm here today to help you understand the Grandstein procedure. The Grandstein is what helps us to see the bacteria either pink to red or blue to purple. This color distinguish gram-negative from gram-positive bacteria. In today's lesson, we need a colony which could be either gram-negative or gram-positive. We also need distilled water, we need loop, we need a microscope slide. We also need a microscope. We need methanol. We need crystal violet. We need locus iodine. We need acetone, and we need the safrinic O, which is the canthus stain. So feel free to learn with us at MedLab Tutors.
MedLab Tutors. Step 1. Prepare and fix a smell. When preparing a smell, we need to label a clean glass slide with specimen ID. For instance, what you see here, we have S1 GPC, S2 GRN, S3 G. This means that slide number 1 will be carrying gram-positive COSI, slide number 2 carrying gram-negative raw, and slide number 3 label G will carry combined group. That means that we will have gram-positive COSI and a gram-negative rod on slide number 3. After labeling the slide, use a loop to add a drop of distilled water on it. This time, we are going to use a new loop to pick up an isolated colony from the plate and spread on the slide. Remember, we labeled a slide G. So here we pick gram-positive and gram-negative that will be made on a single slide. And this is slide number 3. However, every slide we want to prepare, we need a new loop because we are dealing with different colonies. After preparing your smell, allow to air dry on a slide rack. When air dry, flood the slide with methanol to fix or stick the smell on it. Again, allow to air dry. Step 2. Stain the smell. After applying methanol to fix the smell, when air dry, apply the crystal violet, which gives the gram-positive its purple to blue color. Observe your stopwatch for 30 to 60 seconds. After the 60 seconds, rinse with tap water. When rinsed, apply locus iodine and take a 60-second break. It enhances the purple to blue color of gram-positive bacteria. After 60-second break, rinse with tap water as well. Now, decolorize by holding the slide at its angle and applying acetone drop by drop until the purple color runs clear. Rinse with tap water. When rinsed, apply canthus stain, the safrinic O, for 60 seconds. Observe your stopwatch. After 60 seconds, rinse with tap water and allow the air dry on the slide rack. Step 3. Analysis and interpretation. When air dry, add an emerging oil to the smell. Switch on the scope. Place the slide on the stage. Use the 10x to focus the feed and switch to the 100x to view the material. Slide number 2 hides gram-positive Corsi, and so it takes on the primary stain, which gives it purple to blue color due to the ability of the beta-glucan to absorb the ink. Gram-negative raw, slide number 1, will appear pink to red because the primary stain was lost during the decolorization process. It couldn't take on the primary stain due to the inability of the outer layer, the lipopolysaccharide of the gram-negative bacteria to absorb the primary stain, and therefore it takes on the candle stain. This is mixed. It is made of gram-positive and gram-negative, giving it pink to red and purple to blue color. Thanks for watching. Kindly subscribe to our channel.